Okay, so when we're talking about graphing these sine x and cos x graphs, we're looking at, instead of when we graphed before, we did just like 1, -1, -2, 0, all those. When we're looking at trig function graphs, because if you remember when we were doing the unit circle, we were always dealing with 0, pi over 2, pi, 3 pi over 2, and then back over to 2 pi. So we're looking at it in those types of measurements on the x-axis. The y-axis is still using 0, 1, 2, 3, and so on. So for our first one, graph of y is equal to sine x, we started at 0, and then we went up to 1, and then we went back to 0, and then we went down to -1. Yeah, pi 0. Yeah. So then if we went the other way, if you switch to your, I got too many windows open here. If we look just at the y is equal to sine x, so then on the negative side it went down to -1, 0, +1. Okay, so it went -1. Well, not yet. Okay, so our graph went, yeah, sorry, at 1, not at half. I forgot these are at halves. So these should be at -1 and a +1. +1. Yep, pretend that actually touched. And then if we were to continue, it would go back to 0 in both of those. Okay, so if I looked at what my x values were from here, I marked up at 0 at pi, and then this here at the dark line would be 2 pi. So that means in between here, this would be pi over 2, this would be 3 pi over 2, and this would be, here would be -pi over 2. There's -pi, -3 pi over 2, and -2 pi. And if you think of that on the unit circle, this here is at the point 1, 0, which is at 0 degrees. Pardon me? These should be right here at, like it should go to there. My alignment's just off. Yeah, those should be actually going, touching there, but my alignment is off, so it's not exactly perfect. No, that should just be a ticky mark. Those are just ticky marks. So then I know where to, because if I look here at pi over 2, which is here, okay, when that's pi over 2, my sine value is at 1. Right? So this has to do with your unit circle at pi over 2. Remember, this is cos x, this is sine x. Well, sine x needs to be at 1. Pi over 2, I'm up here at 1. Okay? At 0 degrees, if you want to think of it that way, or 0 radians, my sine x should be at 0. I'm 0, 0. Okay, and then over here at pi, I'm at -1, 0. So my cos x, sine x should be 0. So at pi, I'm back at 0. And then if I go down here to 3 pi over 2, oh, sorry, I went the wrong way. negative 1. Hang on, where was I? No, it's right here, 0, because it's the cos x sine x. At pi, here's pi, my sine should be at 0. It's at 0. Where do you see negative? Negative 1 would be my cos x value. Because remember, when you're looking at your values of your coordinates, this is cos x, sine x. Sine x is 0 when you're looking at your theta being pi. Right. Well, and don't think of it as just xy values. Think of it as cos x, sine x. Okay? So at 3 pi over 2, which is right here, my cos x value is at 0. My sine x value is at negative 1. So 3 pi over 2, my graph should be at negative 1. And it is. And then back up here at, 2 pi, it needs to be back at 0. And it is. Yeah. For this one, no. Okay. So now if we look, where am I? Because this point on the unit circle is 1, 0. But my sine value is 0. Okay. So at 2 pi, pardon? No. At 2 pi, okay, which is where that is right there, my sine value is 0. So I have to be at 0 on the graph. Well, my cos, now you'll see when I do the cos, when I do the next graph, my cos x graph, you'll see where that comes into play. This is just from unit circle. Remember, when unit circle, our radius is 1, so whichever point you're at, your x or y or whatever, if this is 1 unit away, then that means my x value is a 1, and I haven't gone off of the y, so it's at 0. No. My y value is a 0. Yeah. Your x is we're looking at where it is at 2 pi. Your x value doesn't really, if you think, I mean, yeah, 2 pi. But we're not looking at x and y values, we're looking at sine and cos values. Okay, so let's look at the cos graph. At the cos graph here, if you look at on your calculators, cos graph is the blue graph on here, so at 0, it's here at positive 1. This would be pi over 2, it's at 0. At pi, it's at 0. 3 pi over 2, sorry, it's at negative 1. 3 pi over 2, it's at 0. And 2 pi, it's back to 1. So I had at 0 degrees, this is my cos value, was 1. At pi over 2, over here, it's at 0. At pi, so pi degrees, where am I at pi? Right back here. It's at negative 1, sorry, I went too far over. It's at 1, or negative 1, and then 3 pi over 2, which is here, I'm back at 0, and then at 2 pi, I'm back at 1. So let's see how that compares with the unit circle. So unit circle, when we're at 0, my cos, good, I switched. My cos here is 1. Okay, that's what it showed on the graph. At pi over 2, my cos is a 0. That worked. At pi, my cos is a negative 1. 3 pi over 2, it's a 0. And then when I get back to 2 pi, it's at 1 again. So then you plot those points. So at 0, I was at 1. at pi over 2, which is here. Why aren't you skinny? There we go. Pi over 2, I'm at 0. At pi, cos is -1. At 3 pi over 2, right there. Yeah. Cos, yeah. They're still there, but you're kind of, we're just concerned about, yeah. This is just unit circle values. And unit circle values, remember your coordinates, your xy coordinates, x corresponds with your cos, what your cos value will be, and y corresponds with what your sine value will be.
So we're looking at our x values. How come we look at 0, 0, and 1 next here, so looking at your x values?
Because that's the coordinate for the whole thing. But in this case, because we're only graphing the cos values, we don't care what these are. Because they're not cos values, those are sine values. But 3 pi over 2 is the measurement we're looking at. That's the theta. Okay? So when my theta value, or my angle value, is 3 pi over 2, my cos value is 0. Okay?
Yeah, but at 2 pi, so at 2 pi is 0, right?
Right, so at 2 pi, when I'm back up here, my cos is not 0, 1. Oh, yeah, I circled it. That's a circle. So it starts out going like this. So then if I continued with my pattern here, if I started at 1, then I'd have to go back to 0 at negative pi over 2. These two correspond, right? And then at pi, I'm down to -1. Or negative pi, I'm down to -1. And then when I'm at 3 pi over 2, I'm back at 0. And then at -2 pi, I'm up here at 1. So when you're doing these graphs, you're thinking of, instead of this, thinking of it as your x value and your y value, this is your theta value. Okay, so when theta was 3 pi over 2, cos was, yeah, yeah, exactly.
Don't worry about both.
Don't worry about both, that's right.
Makes sense, though?
Okay, so it says trig graphs are called periodic graphs because they repeat themselves over a given period. So if we looked at this, we started at 0, 0 for both of them, and we went, for the sine graph, it went up, and then it came to 0, went down, and then came back. If we looked at it going the other way, when we started at 0, went down, 0, back up. We can continue this, and it's basically just a wave pattern. So our sine, if I just started at the 0, it's going to keep going like this.
Plus 1 max, minus 1.
Yeah. Yeah, it's between -1 and +1.
That's like the unit circle.
Yeah, exactly. Okay? So what is the period of the graph of y is equal to sine x? When does this graph start to repeat itself?
After it goes from 5 to, or from 0 to 5.
Right. So right here then, if we forget about this side of the graph, if this was actually, it would go back here. Whoops, let me do it in red. So it would go to here, and then come back down, go down there, back to 0. And it would continue like that. So the period is going from here to here. So that length from 0 to 2 pi is just called 2 pi. Up, yeah. Right, so y is equal to cos x. I started at, when my theta value was 0. I started at 1, so the next time I start at 1 is here at 2 pi. So that means that my period for this one would also be 2 pi. And you could shift that left or right, but it doesn't matter what shift you do, it's still going to repeat itself after 2 pi.
Can you do this with tan, or do you have to make little old triangles, or?
Tangent is a little bit different, and we'll do some tangent at the end of this one. It still repeats itself, it's just got a different period where it repeats itself. Okay, so the next part says label the following key features on the graphs. So we want our center line, which is also called the vertical displacement. And all vertical displacement is what is the line where, exactly, half of the graph is below it and half of the graph is above it. Yeah, it's kind of an axis of symmetry, but instead of being an up-down axis of symmetry, it's a horizontal. Oops, that should go with that one. I wrote it a little high. So it's the center line, or the vertical displacement, is the line where half of the graph is above and half of the graph is below. So for both the sine x and the cos x graph, it's that. Y is equal to 0. So amplitude, you talk about amplitude in physics when you're dealing with waves, right? So amplitude is just how far from the center line you're going. Kind of, yeah. You want to think of it that way? So amplitude is telling you how far from the center line does the graph move. And it's always positive because it's measuring a distance. So even though our graph goes down to -1, it's still a distance of 1 from that center line. So for this one, for these graphs, our amplitude is equal to 1. Yeah, right now just sine and cos.
Points, would you put all the points down, like pile for the single side, pi over 2, and put -3 pi over 2?
Those would be restrictions on your graphs. That would, like, so for this one, we only looked at the graph from -2 pi to 2 pi. So that would be like our domain values. Okay, and those can be anything, but those can be given, and if it's not, then usually you just graph it for one period unless it says differently. So when it's looking at minimum and maximum values, if you think about when we were graphing parabolas, that was always your y values. What is the highest either y value you can have, or what is the lowest y value you can have? So for these ones, because parabolas, we just either went this way or we went that way, we either had a minimum or maximum. For trig functions, we're doing both. We're going up and we're going down. So you're going to have minimum and maximum values for your graphs, for your trig function graphs. So for these ones here, y was equal to 1 is a maximum value. That's as high as we could go. And y is equal to -1 was your minimum value. So this basically is the same thing as your range. So y was in between -1 and 1. So you could write them either way.
And you want to put your minimum first. Right?
Yeah. So then the last part on this page says each period of the sine and cosine function can be divided into 4 equally spaced sections. Label them on the graph, and what do you notice?
Equal space.
Yep. So if you look at here, this graph is already divided for you because of where the dots are. But if our period is going from 0 to 2 pi, if you look at this, I'll use green. If we start here and end here, that's one period.
See all 4.
You have one here, and one here in between. So here's 1 space, 2 space, 3 space, 4 spaces. Those are your, yeah, and I'm trying to think of the word that we use for them, and it's just lost on me right now. They're kind of our key points, okay? Because we had at 0 here, it was kind of our start. If we started at 0, then that was where our starting point of the graph was. 1/4 of the way at pi over 2, we hit a maximum value. And then another 1/4 of the way at pi, we went back to 0. Another 1/4 of the way at 3 pi over 2, we hit a minimum. And then 1/4 of the way, which got us to 2 pi, we were back at 0. So those are our key points, would be at 0, pi over 2, pi, 3 pi over 2, and 2 pi. Well, I counted this one, but your beginning one, if it's 0, isn't really where it's where it's divided into. So we've divided it here. So, well, it's the period between 0 and pi over 2. That is one of the spots. Your next spot would be from pi over 2 to pi, and then your next quarter section would be from pi to 3 pi over 2, and then 3 pi over 2 to 2 pi. Okay, and it'd be the same thing with our cosine graph. If we looked at just from 0 to 2 pi, our sections would be divided here. So this would be the start, this would be the end, here would be your key sections. So what do we notice? The 4 parts with the 4 parts match up with 4 key points on the graph. Can I turn? Okay. So it says, test yourself, sketch 2 periods of the sine and cosine graph. So just on your own, either take a look at your calculator and see if you can put these on here without flipping back to the other page. 2 periods means, so 1 period goes from 0 to 2 pi. So in this case, then we're going to go from, yeah. So do it without looking at the other page is all it's saying. Almost, yeah. Nope, it's the same. Exact. You will need them for the long as you know. Doesn't matter. Okay. Then negative pi over 2 is in between 0 in the first graph, so it would be right here. Halfway in between 0 and pi, and negative pi. So, yeah, there wasn't any there. So, 2 periods of the graph just means that your graph will repeat itself. So for the sine graph, if we start at 0, then it's going to go 0 up to 1, back to 0, down to negative 1, back to 1, and then going in the opposite direction, then it's just going to be the reflection of that. It's going to go down negative 1, 0, 1, back to 0. The difference between cosine is instead of starting at 0, it starts at y is equal to 1. So we go 1, 0, negative 1, 0, 1, 0, negative 1. So you can see it does a repeat. Two period. So this is 1 period here. This is 2 periods. I can continue this. There would be 3 periods. Okay? Good. So using our knowledge of transformations, what happens if we put a 2 in front of our sine x? That's the equivalent of an a value. So what does that affect, your x or your y? Your y. Right. So if on our sine graph here, when this was y is equal to sine x, for this one, if it's a 2, that means that we're going to double our y values. So instead of our 0 values are going to stay the same. Let me pick a, see if that one shows up. So my 0 here at 0 pi and 2 pi, it's still going to be 0. That's way too late. Let me use orange. So at 0 pi and 2 pi, those are still going to be 0. And I can do that on the negative side too then. So at negative pi and at 2 pi, negative 2 pi, sorry, 2 pi, those will still be 0. What's going to change then are these 1s. So at pi over 2, pi over 2, which is halfway in between 0 and pi, and then at 3 pi over 2, we're going to have, instead of a value of 1 and negative 1, we're going to double it because a is a 2, so it's going to be up at 2. And then at 3 pi over 2, it's going to be down at negative 2. So then that means on the negative side of the graph, at negative pi over 2, it's going to be down at negative 2. And then at negative 3 pi over 2, it'll be up at 2. Exactly. So if this is my transformed graph with that amplitude there of 2, this would have been my normal graph. Where's my 1? Oops, I skipped my 0. So that would have been my regular graph. In red. Yeah, the red graph is my y is equal to sine x. The orange graph is y is equal to 2 sine x. So that cos x, my zero values were at pi over 2. So right here was a 0. And then again at 3 pi over 2. So then on the negative, at negative pi over 2, that's still going to be a 0. And at negative 3 pi over 2, it's going to be a 0. So my normal graph, when it was y is equal to cos x, started out, went from 1 to 0 to negative 1, back to 0 to 1 again. And then it went 0, negative 1, 0, positive 1. That's a bad graph, but you get the gist of it. That would be your normal graph. Y is equal to cos x. Right. Yeah, that's just y is equal to cos of x. Y is equal to 3 cos x then means that those y values that were at 1 and negative 1 are going to be tripled. So instead of being at 1 here, it's going to be at 3.
Will we ever have like a basic graph where it's not on a linear?
Where it's not, well, like this one right here. Y is equal to 3 cos x. Your basic graph is always going to be. Okay? Yeah, find your zeros first. So then if I went on the negative side, I'll be at negative, or back at 0 here, starting at 3, 0, down to negative 3, when it's negative pi, back to 0, and then up to 3. So my amplitude for this graph then would be 3. My maximum and minimum values would be at 3 and negative 3. Didn't change my period. I still went at every 2 pi, I repeated myself. So it said, what did the A value do to our graphs? Right. Right. Yep. Because remember we talked about vertical stretches? In vertical stretches, horizontal, or stretches or compression, same thing. So stretch them vertically. Well, it didn't just increase them though, because it's increase means you've added something to it. But we've magnified it, or like the amplitude is a multiplication. So that's why I don't want to say it's increased, because increased usually means you've added something to it, but we've actually multiplied. No, we haven't added, we've multiplied. Right. So amplitude is just then your vertical displacement from the center line. I have to look in your... I don't
I
know.
hope I did. That's why I didn't.
Yeah, no.
That's why I did the whole map that students that you never just circle. Some people don't touch it. Like, that's how we do it.
So your amplitude, if you look at this, our amplitude was a 2. This whole graph, though, moved, the whole displacement from top to bottom would be 4 units. So it's actually, amplitude is half of the distance that your graph moved.
That's the formula for it.
Whoops.
I really increased.
So if we look at this one, our formula, our amplitude would have been from 2. So from this one, it would have been from 3 minus negative 3, or 3 plus 3, and we divided it by 2. Our amplitude is 3. Half, because the full amount that this graph moved would be 6. But basically, that's what it is. Yeah, 3 minus, because we went from our maximum point of 3 to our minimum point of negative 3, and then we divide by 2.
Is it just,
No, not 1.5, because I moved a distance of 3, not 1.5. All it is so that you have the formula. Yeah. Yep. Amplitude is just your maximum point minus your minimum point, divide by 2.
that's what Paul you know.
Max minus minimum. Yep. So 3 minus negative 3 is 3 plus 3, and divide by 2.
It's confusing me as this one's
Yeah.
0.
Yeah. Okay, because this graph moved, instead of just moving a distance of from 1 to 1, it's gone from 3 to negative 3. So if you counted up these distances, it's gone 1, 2, 3, 4, 5, 6. So your amplitude is half of that distance. That's all it's saying. That's it. Max minus minimum equals 2. So for this one, this particular graph, our amplitude, if you didn't have the actual graph like this, the equation, if you didn't have this, if they just gave you the graph, then you could look at it and go, yeah, just count, or yeah. Right. So it says for trig graphs, the horizontal stretch, so we haven't looked at horizontal stretch yet, but if our vertical stretch is affecting our amplitude, then our horizontal stretch, so where it's going to affect it going across this way, is going to affect the period. Right now our period at normal is 2 pi for sine and cos graphs. When we do something in here, it's going to affect the period. This actually should have been on the next page. That's yeah. No. Well, there's 4 sections, but I've taken the tangent section and plugged it into 5.1 and 5.2. Oh, just bad.
Well, you threw tan in there.
Okay, so it says compare the periods of the following graphs on your graphing calculator. So on your graphing calculator, put in y is equal to sine x, clear y is equal to cos x, and then put these other ones in.
Why is it focused? Put them all in there?
Charles, put these in your calculator.
There's one at the period there.
So we just take that 2 pi and multiply it by the number affecting x.
I don't know, let's... Oh, you can use this one. Where's the one that's signed out to you? Okay. Ooh. Okay, I don't want to do all of these on here. Yeah. Yeah, there is one. There's two more after this. I'm not going to put both of them on here. I'm just going to look at one at a time. Okay. Shh. Okay, so let's take a look at the first one. Y is equal to sine x compared to y is equal to sine 2x. So y is equal to sine x, and here is my red graph. So if I start at 0, and then 2 pi is where I go back, and I start repeating again. If I look at y is equal to sine of 2x, I go from 0, and then at pi I start repeating it again. So what has it done to the period? If my period initially was 2 pi and now it's only 1 pi, by how much? Half. Exactly. So y is equal to sine of 2x has half of the period of y is equal to sine x. So I have to go on my sheet. So in this one, my period was equal to pi. At pi, it repeated. At y is equal to sine x, my period was equal to 2 pi. So what was it at y is equal to sine of 4x? Okay, so at y is equal to sine x, I repeated here at pi over 2. By the time I got to 2 pi, I had 1, 2, 3, 4 repeats, or 4 cycles done. Right. So then, for this one, my period was equal to pi over 2. At y is equal to sine of 1/3 x. So Jamal came up with the conclusion that when it's a whole number, your period is getting squished, it's getting smaller. So he said, so that means when it's a fraction, it should be getting bigger, or stretching it. So let's see. Oh, okay. So y is equal to sine So y is equal to sine of 1/3 x. I'm going to have to scooch in here a little bit. So normal graph, 0 to 2 pi. This one, I went 0, and then I don't go back again to the 0. I'm going to have to keep going. And when we look at it here, then I'm back. It's flattening it, yeah. But it actually isn't. If you look here, this line here is going down to same as 1, right? The y hasn't changed. Yeah. So if we look here, this is 1, 2, 3, 4, 5 pi, and then it takes me till I get way over there. Oh, right, sorry, right here is where I'm back at 0 again. So that'll be at 6 pi. Okay, so instead of being at 2 pi, it's right here, 0, and then the next time I do my up down back is when I'm at 6 pi. Mm-hmm. Yeah. So then this one here is thrown in the negative. What's negative going to do?
It's gonna go.
Flips it, right? So if we do a negative, where's my negative sign? So instead of going regular graph y is equal to sine x, I go 0 to a positive 1. On a negative, I went 0 and then I went down instead. Because it's a negative. We put that negative in there. Let me do yep. Y is equal to sine, and if I do a negative x, okay? So my black graph here is my negative sine x graph. So it's the exact opposite. Zeros stayed the same. Zeros will always stay the same, but I went from positive x value, I'm up at the positive first. A negative x value, I'm down at the negative first. So, okay, if I look at my orange graph, I went from 0, because that's a 1/2, from 0, and then I don't go back again. I don't repeat this cycle till I'm at 4 pi. Okay, I go 0, down, 0, up, back to 0. So I need to do an up-down or a down-up in order to complete a period. So down, up, back to 0 is 4 pi. It's still a period of 4 pi. Because it's a distance, it's still a positive value. No. It's still a distance of 4 pi. Okay. No break. So my period, I wrote them in here. What's happened is that we call it that horizontal stretch factor. Not today. No, we didn't plan it yet. So horizontal stretch factor is how much are we either stretching or compressing, depending on if it's a fraction or a whole number. So for this one, the first one, the horizontal stretch factor, we took our 2 pi and we divided it by 2. So our horizontal stretch factor would be 1/2. So what would the horizontal stretch factor be when it's a 4? Right. Because we took our 2 pi and we divided it 4 times to get it to be a pi over 2. Yeah. Yes. B. Yeah, from when we did the other transformations, our B value affected the X, right? Affected the horizontal. So what's our horizontal stretch factor if it is a fraction, or 1/3? Right, so we stretched it out, it was 3 times, it took 3 times as long to complete that. So instead of a period of 2 pi, it was 3 times that, 3 pi, or 6 pi. So then that means this one here, our horizontal stretch factor, and we forget about that negative for the moment, it was, nope. All we need to know is that negative is going to flip it. Okay, So it says the function y is equal to sine of bx and or y is equal to cos of bx have a period then equal to 2 pi is our normal, right? And what we did is we divided it by whatever our b value was. No, absolute value. Because we don't, in this case where that negative was, didn't matter that there was a negative, it still had the same horizontal stretch factor. So horizontal stretch factor, we write it as 1 over the value. So horizontal stretch factor is actually 1 over absolute value of b. So that's where this one, our b was a 2, so it's a 1/2. This one here was 1/3, so just the same thing, which is, right. Okay. And if this is if you're dealing in radians, in pi then in degrees it would just be 360 over absolute value of b. Most of what we're going to be dealing with will be radians, will be in using the pi's. I'm not sure. Not once you get into the higher maths. Okay, so the next part says graph 1 period by hand. So we need to look at this. Our b value is equal to 4. Okay, so then that means that your period is going to be 2 pi divided by 4. Sorry, not pi over 4, pi over 2. Okay, so that means every pi over 2 your graph is going to be repeating. Yep. Mm-hmm.
The middle of that would have to be half pi over 2 or pi over 4.
Halfway in between here, that would be pi over 4. Yep. Well, you could, but that's kind of cumbersome. It'd be better just to write it as pi over 4.
What would the other part be? Pi over...
It'd be...
Pi over 8 and pi over 4.
Well, this would be... So this one is pi over 2. So if you think of it, that would be... No, it wouldn't be pi over. It would be 4 pi over 8, if you want to think of it that way. So it would be 4 pi over 8, because that's a half. So then halfway there, that would be 2 pi over 8, which is a quarter. Okay. Okay. You can do either one. So the first thing you always want to do, you want to find out, girls, we figure out your period. So I know my period between 0 and a half pi. I have to have done my that. Okay? So I need to mark my 4 key periods in there. So this one, they've got the nice little grid because we on that other page, we said there's 4 key points where things happen. Okay? So those are where our key points are going to be. So we know that at 0, that's just a starting one. We don't actually count that one. So we have 1, 2, 3, 4. So at these 4 points here, something has to happen. In this case, because it's a sine graph, or sorry, at a cos graph, I know that I start at 1, right? So I want to look for my zeros. Where are my zeros? Well, if I'm starting there, then it's going to be here, then it's going to have to go down, then it's going to come back up here at 0. Yeah. Because I have to take my 1/2 and divide it up into 4. Well, then this would be halfway between 0 and pi over 2. You just would divide.
Just like how would I know, like if you didn't already like make the graph, especially like that, that I would know where each point.
Then what you do is you just, because you could have actually made this go from 0, this could have been your half pi. Yeah.
You'll know it's
By the-
0.5,
yeah.
pi over 2, right? And you'll know that's your period, so you start with 0.5.
You start at 0.5 and then just divide the other equally. Okay, so I know starting I'm at 1, and then I'm going to 0.
That's your original?
Yep. No, this isn't my original. This is my graph now. I'm squished it into the 1/4. Or into that. Yeah, I can't.
Don't you keep 1 and times it by a quarter?
No, because there's no value in front.
Oh, yeah. That's a lot.
Yeah, it doesn't affect the y. I'm only affecting my x.
And you already squished it?
Yep. Mm-hmm. So you divide your graph into the 4 even parts. You mark where are the zeros. So I know on a cos graph I don't start at 0. My next spot is my 0. So I didn't start at 0, I had to start at 1. So then I know the next section has to be 0. The next one over I have to go below, but then I'm back up to 0 in that third section.
You'll get those memorized.
Yeah. Yeah. So that's what one period would look like. Mm-hmm. Oops, put that in the wrong spot. Okay. Well, I want to finish the notes and then you can have a break.
Oh, you got in those.
I'll take my chances. Okay, y is equal to sine of 1/3 x. So this means my b is equal to 1/3. Oh. So my period is equal to 2 pi divided by 1/3, which is the same as saying 2 pi times 3. So it's 6 pi.
All the way to 6 pi.
Right, so my graph that I've given you here only goes to 3 pi. So I have to travel a distance of 6 pi in order to show one full period. I could show a half from here to here, but if I go from negative 3 pi to 3 pi, that's a distance of 6 pi. Mm-hmm. Okay, so then that means if I divide this into my quarter sections, this is a sine, yeah, so that'll be 0. Yeah. So then here would be where one of my key sections would be, then at 0, and then there, and then at 3 pi. So it's actually 1.5 pi, right? So I went from negative 3 pi to negative 1.5. So I've divided my 6, and if you do that, if you go 6 divided by 4, well, I know every 1.5 I have to have a key point. So this is...
half is like 3 pi over 2.
Mhm.
Divide that by.
Yeah.
6 divided by
That's all I did. I took my 6 that I went, I needed to divide it into 4, because 6 divided by 4 is 1.5, so I have to take 1.5 off every time when I'm moving.
And start at 1.
Yeah. So I know at a sine graph I have to start at 1, or sorry, I start at 0 on a sine graph. Yeah, this is sine. So I know then from before that I start at 0, and then halfway through my graph I'm at 0, and then at the end I'm at 0. This is from a sine graph. Just from what? At the beginning, halfway through, and at the end. Because if I think that this is what a sine graph looks like, right? So at the beginning, halfway through, and at the end, I'm back at 0. Because of the period. Because I needed to graph in. To do one full period, I have to cover 6 pi distance. So if this graph here actually had gone, if this had continued and I had actually to 6 pi, I could have done it all on this one side. So I know from a sine graph, I start at 0, and then 1/4 of the way through, I'm up at 1, and then I'm back at 0, and then the next quarter of the way through, I'm at -1, and then back at 0. Oh no, that's okay. Oh, hang on, sorry. I did these 2 dots wrong. Because I have to remember that 0, if I forget about this side of the graph, I have to go up first. My sine graph goes up first. So this should run up, down, and then this should have been a down here. Because normally my graph, if I had done my 6 periods, or my full period at 6 pi, I would have been down, up this way. I started as if this was 0 here at -3 pi, but I still have a 0 value, so yeah. Say that again. On our original graph? Because that was at y is equal to sine x. So I know between 0 and 2 pi. So my normal graph, if I had done y is equal to sine of x, if this was it here, I would be going 0, and then I have to end halfway through, would be here and here. So my graph would go like this. That would be for a normal. Well, it's because I couldn't finish all of my graph. My graph paper wasn't big enough to finish up to 6 pi on here. But if I had been able to, it would have went from here to here and then back again. But since I couldn't show that physically on this graph, then I have to show it going on the other side. So that's only because of the graph paper that you did that. Okay, so this is putting both of these things together. You're putting your amplitude or your vertical displacement and your horizontal shift together for this one. So I have 3/2 sine 2x. So for this one, maybe I'll do this in purple. My a is equal to 3/2. So that means instead of being at 1 and -1, I'm going to be at 3/2 and -3/2. 2x means that's going to affect the period of this graph. So normal is going to be 2 pi, but right, since my b is equal to 2, okay, so my b value is equal to 2 in here, so then that means my period is going to be 2 pi divided by 2, so it's going to be at pi. My key points then, you take whatever your new period is and divide it by 4. So every pi over 4 is where I'm going to do those key points. Because the key points is what we do. Every quarter we have a key point. want to look at my,
Like two
what?
unit circles got 4 main coordinates, right? 0, 1,
Mhm.
0, that's why you have 4.
Yes. If you want to think of it that way. So my normal graph, if I was doing y over sine x, normal period would be over 2 pi. This graph doesn't extend to 2 pi, it only does 1 pi. So normally I would be going from here to here. Yeah. If it had continued, then I'd be going down to 1, and then at 2 pi, I'd be back up at 0. So that would be normal. That would be y is equal to sine x. Y is equal to 3/2 sine x means that now instead of at my key points, instead of being at 1, I have to be at 1.5 or negative 1.5. So if my whole period is done in pi, so this is pi here, every pi over 4, I need a key point. So that means here's pi over 4, here's pi over 4, there, and then that's my last one here at pi. Okay. Yeah, that's pi over 4, so that's going to be where a key point is. So, because every pi over 4 is where I do, and it's just counting your tick marks. And since this one has told us this is 1/2, then I know halfway between 0 and a half is a quarter. And I know that halfway between a half and a pi is a 3 pi over 4. Colin? That's right, it's going to do a full curve. So this isn't this graph. Alright, this graph's going to be in purple. This is y is equal to sine x. Nice. So that means on my sine graph, at my first key point is 0, I'm at 0. And then I go up. This one is a 3.2 or 3 over 2, so 1.5. So that means at my next key point, which is 1.5, I'm going to be up. At 0 point, my next key point, I would have to be back at 0. The next key point, I have to be down at that 1.5, and then I have to be back at 0. Which part? So the A just means that instead of being 1, I have to take whatever, multiply A by 1. So 1 times A would be 1 times 3 over 2 is the same as 1.5. So that means I have to, yeah. Part 3 over 2. 3 divided by 2 is 1.5.
And it always goes back to that 0, right?
Yeah, and then it goes to 0.
And what happens after that?
Then it goes down, and then it goes back to 0. So it's always, sine is always start 0, go up 0, go down 0. And it just depends what your A value is, whether you're going up to 1 or you're going up to a 17 if A was 17. Okay.
How come at 0.5 pi,
Mm-hmm.
your graph, that one is going back to 0? What happened?
Because I've only done half of my cycle. So normally, if this had been continued, so let's say that this was continuing on here. So if this would have been pi, then this here, we'll call this one would have been 3 pi over 2, and then 2 pi would have been here. So my graph would have went like that. But since this graph didn't, it stopped at pi, then I had to stop my first cycle at pi. Okay. So y is equal to 1/2 cos 1/4 x. So my A value here No, if this was a negative, then it would flip it, but it's not a negative, so it stays. My b value is equal to 1/4. So then that means my period is equal to 2 pi divided by 1/4, which is just 2 pi times 4. So then that means my key points, right, are at 8 pi divided by 4, 2 pi. So every 2 pi is where I'm going to do my zeros or my up value or down value. So this graph here doesn't go to 8 pi, but I need to go a distance of 8 pi. So that means, so I'm going to go from 4 pi to negative 4 pi, which is a distance of 8 pi. So within that 8 pi, I have to do that graph. Yeah. Right. So if I divide this into my key points, so then at 4 pi, 2 pi, 0, negative 2 pi, and then of course negative 4 pi is where it would start.
It's funny though, I thought at cosine never, 0, 0 never occurs.
Right, 0, 0 doesn't occur. It has to start at 1. So a normal graph would start at 1. Y is equal to cos x. Would start here at 1. But because this, oops, I'm doing red. Because this is a 1/2, that means I'm going to start at 1/2. No, one cycle's got it. This is one whole cycle because it's 8 pi. Y is equal to cos x, yeah, would be 2 pi. Yeah, so normally this graph, the blue graph normal would be like this. Oops, I got my point wrong there. Yeah. So that would be normal. Okay? So this one, at my key points, that's where I need to do my changes. So I'm starting at 1/2, then that means my next key point I'm at 0. And then at the next key point is when I'm going down. I went up 0, so now I have to go down. So that means at negative 1/2 and 4 pi I'd be down. At 4 pi it's at negative 1/2. Because that's where a key point has to occur. Not at pi. And then at my next key point, I have to go to 0, because that's what this does. It starts up, and then it goes to 0 at the next key point. Yeah, so now because of that stretch. So then that means, then after I do my 0, then it goes down. Right. So my next key point then going the other way would be at negative 2 pi. So that means that I'm going back down. Back to 0. And then, yeah, kind of, I guess. And then at my negative 4 pi, I'm going back down again. So it looks like this. It's kind of a hill. So I've done my up, down, but because I couldn't continue this one, if this one had been able to continue, then it would have gone at 6 pi here, it'd be back up.
So that right there.
Or 8 pi, I mean. Pardon?
That done.
Yeah, this is done now. From negative 4 pi to 4 pi is my full period of 8 pi. I've gone down, up, or sorry, down 0, up 0, down. So I've got my 2 zeros. Within one period, you need to have 2 zeros, and one up, one down. Okay, so,
So when you divide that 8 by 4 together with different
yep, key points.
points, how do you know which ones are zeros?
Every 2, right? 'Cause it's-
Yep, every second one, right. So if this had continued here, this would be at 6 pi, I'd be at 0, and then here at 8 pi, I'd be back up at a half. So that would have been my 0, 0, up, down, and then back up. Okay? I'm going to stop there. What I want you to do then is just the first part of the assignment. So this page 233, this is on the sine and the cos graphs. And I have, no, it's still there, but I'll do that, and you can watch that video over the weekend. Where am I?